Okay, hopefully everyone can see my screen now. Yes?
Yep.
Perfect. Okay. Great. Awesome. So let's talk about loops and debugging. So this is our first kind of session. And once again, like I said yesterday, the first day or two, a lot of it may seem like review, but I guarantee you this is going to kind of build on top of build on top of each other and get more difficult very quickly. So just bear with me if some of this may seem a bit redundant for now. Okay, so today we're going to talk about loops and then also some basic debugging techniques here. Loops are by far one of the most common things you will use in not just JavaScript, but really in programming. If you think about it, it makes perfect sense, right? Computers are really, really bad at ambiguity, but computers are phenomenal at doing the same thing over and over again, thousands, if not millions of times. And so whenever we want to do something more than once, typically speaking, there's probably a way that we can do that in a loop format that actually not only makes it easier for us to write, but it also makes it a lot clearer to whoever's reading the code exactly what's going on. So there are several kinds of loops. Here we'll talk about predominantly the while loop and the for loop, which are going to be the most common ones that we see. So as a quick review, for the while loop, there's three keywords. There's the while keyword, there's a conditional expression that evaluates to a Boolean value, and I'll talk about what all of those words mean in just a little bit. And then thirdly, we have the block of code. Okay, so if I look at the example here on line 6, even though it's commented out, notice how on line 6 I know it's a while loop because initially on line 6 it starts off with the word while, and so in JavaScript there are a bunch of words that we call reserved words, and when you type them in most code editors, the reserved words will actually show up in a different color, and this is just to indicate that hey, this word is part of the language itself, right? Kind of like when I use the word let or for or a lot of these other words. These are reserved words, which means they come predefined in the language. And what that also means is I cannot create a variable called while. I cannot create a variable called let. I cannot create a variable called var, right? And so these things are just kind of rules that you'll see. And most code editors, because they change the text color, it actually makes it really clear to you when you're using something that you probably shouldn't be using because it's a reserved word. In any case, on line 6, we have our while keyword there, which indicates the start of a while loop. In our parentheses, we have a conditional, and we'll talk more about conditionals tomorrow when we talk about coercions and truthiness. And then lastly, we have everything, we have the opening curly brace, a block of code, and our curly braces. And so everything between those open and closed curly braces is what we call a block of code. And so the basics of the while loop is that the block of code there will run over and over again as long as the conditional becomes true. So what does that mean? Well, here let's take a look at a quick example, right? On line 1, I create a variable called count, and I set it equal to 3. On line 3, I have my while keyword, which means I'm in a while loop. Inside of my parentheses, I have what I call my conditional, and then I have my block of code, and all the block of code does is on line 4, it console logs out count is, and then the actual value of the variable count. And then on line 5, I decrease count by 1, right? Minus minus just means we subtract 1 from count. Okay, and so when I look at this code here, what line 3 is saying, how the while loop is going to work is the first thing that a while loop does is it always calculates what's in between the parentheses. It always calculates the conditional first. Okay, and in this case, we see that the conditional says count is greater than or equal to 1. So we are making an assertion here. We're saying count is greater than or equal to 1. Well, the first time we do this, what's the value of count? Well, count is defined on line 1, and we initialize it to a value of 3. So the first time we check this basically boils down to while, and then in the conditional, we have 3 is greater than or equal to 1. So is that true? And the answer is yes, it's true. So for that iteration, for that loop, the 3 is greater than 1, and that means we execute the block of code. Okay. So when we execute the block of code, line 4 runs, and we console log out count is, and then the value of count, which was 3. And then on line 5, we decrease 3 by 1, right? We do count minus minus. Now, that's the first iteration of the while loop. A while loop does not stop until the conditional eventually becomes false. So by virtue of us running the first iteration, it must mean that we start trying to run a second iteration. So when we start trying to run the second iteration, we now check the conditional again. And in the second conditional, it's still whether or not count is greater than or equal to 1. But now, remember how our value of count has changed. The first time we ran this loop, it was 3. But in the body of the loop, in the code block on line 5 there, we decreased 3 by 1, so now count is just 2. And so now when we check whether or not count is greater than or equal to 1, we're actually checking whether or not 2 is greater than or equal to 1. And the answer is that's true. It's also greater than or equal to 1. So then we do our code block again. We run line 4 and then line 5. And then because we haven't stopped yet, we just keep going. We then check one more time, is count greater than or equal to 1? Except now count is no longer 2, it's now 1 because we subtracted 1 in the previous iteration. Is 1 greater than or equal to 1? Yes, it is. It's equal to 1. And therefore the loop runs one more time. And then because we don't know when to stop yet, we're going to try running it a fourth time. On the fourth iteration, when we check our conditional of whether or not count is greater than or equal to 1, at this point, count was 1 the last run, and we subtracted 1 from it, so now count is 0. And at this point, when our conditional checks it, it basically checks is, hey, is 0 greater than or equal to 1? And the answer is false, or no, it's not. And so because that conditional is false, our while loop can only then be finished. And so this is what we mean when you say that the while loop just keeps running over and over and over again until the conditional becomes false. Okay, and so on the top right hand corner of your screen, if I do run this block of code or this piece of code, the top right hand corner of your screen is what gets printed out, right? When on the first iteration, we print out count is 3, then we print out count is 2, then count is 1, and then finally, after count is 1, count becomes 0. But when we do our conditional, when we check to see whether or not 0 is greater than or equal to 1, we get back false, and therefore our while loop terminates at that point. Okay? There is no guarantee that a while loop is ever going to run at least once, right? In this case, I have a while loop here. I have all the parts. I have my keyword, I have my conditional, and I have my code block. But my conditional immediately defaults to a false. So when we run this while loop the first time, it's going to say, okay, great. Is my conditional true? Nope, it's not. It's just false, and it's always going to be false. And so at that point in time, the while loop just finishes right away. And so just because you see a while loop doesn't mean that it's guaranteed to run, right? It may never run if the conditional starts at a false. And then we have the opposite problem here, whereas if we keep it as a true, well, if I run this function, because in line 1 the conditional is just true, nothing's ever going to change that. And so when I run this function, this is going to run infinite times, or more accurately, it's going to run until the computer runs out of memory, in which case it will break too. So these are just two conditions you need to be aware of, is that if it's false, then it means it will never start. And then if it's true, it means it will never finish, right? And so what that just means is, whenever you write a while loop, you should always be checking to make sure that when your conditional evaluates, that it's slowly it's gradually moving you more and more towards a world in which the conditional is going to be false. Okay, so if I look back on this example here, this looks just like the code that we started our example with, except now we took off the count minus minus. So therefore count is 3, and then when we check to see whether or not 3 is bigger than 1, and we never change count, we run into the same problem we had before, right? Which is that, hey, if count is 3 and it's greater than 1 and we never change count, but every time we just keep checking to see if it's greater than 3, well, it's always going to be true, right? So we have what we call an infinite loop. And so the rule of thumb here is just that every time you run your while loop, you should theoretically be getting closer and closer to a point in which your conditional is false. Okay, so every time you run it, you should be getting closer and closer to finishing. Any questions there? Everyone good? Okay, awesome. Someone wrote something. It's really annoying I have to exit out of the share mode to read text messages. Yes.
Oh, sorry, I was just saying.
Yeah, next time just shout it out. I also like to sometimes feel like I'm not talking to just 14 gray boxes
Okay.
occasionally. Cool. All right, so that's a while loop. So then the other type of loops that we're going to talk about is something that's a lot more commonly used. Because if you remember the while loop, there is always this chance that if you're not careful, it could either never start or more scary in some ways, it could never finish. A for loop is another loop that people use more often because in some ways it could be seen as a little bit more safeguarded, right? So a for loop also requires three elements, although we're kind of cheating with number two there. The first thing it requires is the for keyword, right? So for is also a reserved word in JavaScript. It means something very, very specific and you can never change it. On number two, the thing it needs is actually three different things, and we'll talk about what those three expressions are. And then the third thing is it needs a block of code. Okay, so the way that the for loop works, sorry, the way that the for loop looks is kind of like this. Between lines 6 through 8 there, we have our for keyword. Now instead of having a conditional in between the parentheses, we actually have three things in between the parentheses, and we'll talk about what each one of these things are. And notice how each one of those things is separated by a semicolon. Very important. A lot of times when people are first starting off, they might accidentally use a colon or a comma or something, and the code is going to break and actually going to give you some really kind of, sometimes indecipherable error. Just remember to double check and make sure you're using semicolons to separate each of those three elements. And then finally, we have our block of code, which once again is denoted by the open and close curly braces, right? So the first and the third thing, the for keyword and the block of code, looks almost identical to a while loop, right? That hasn't changed yet. What's changed here is actually the things that are in between those parentheses. A for loop has three parts. There's an initialization, there's a condition, and then there's what we call the final expression. So let's talk about what each one of those things are. A for loop is something that you use to run loops, right? To do something over and over and over again. If I was to ask, for example, you to do something for me, a lot like over and over again, what are the questions that you want to know? Well, the questions you want to know are, when do I start? Uh, sorry, when do I start, and how do I know when to stop? Right? Those are the two most important questions that every loop you kind of need to tell every loop. Okay, so the initialization part of it is the first thing that's run because that essentially tells us, hey, where do I start, right? Like, when do I start? And notice how in the first bullet we make a note, initialization is only run once. It's only run the first time because essentially what that's used for is to keep track of almost how many times we've run this loop, okay? The next part, the middle part, is a conditional, and that conditional looks just like the conditional in the while loop, right? It's a statement that that's either gonna become true or it's either gonna become false. And once again, just like in the while loop, that true or false, that's gonna tell us whether I should keep going. Sorry, um, that conditional is gonna tell us whether or not we should keep going or we should end the loop, right? So basically, when do we stop? I guess is a more accurate way of talking about it. And then we have something called the final expression, and that's just something that we use to kind of to modify the counter. Okay, so when we see how it's run, you actually see how it's in some ways very, very similar to what we saw with the while loop. Okay, so in this for loop here, the first part, right? When I say the first part, I mean everything before the first semicolon. All we're doing is we're creating a variable, in this case I, and we're saying let I equal to 1. Okay, that part only runs once in this entire for loop. We only create one counter. If we create a counter every single time we run this loop, well, there's pretty much no point, right? Like, we're not keeping track of anything then. So in that case, it defeats the purpose, right? So just remember that this let I equals 1 for this run of the for loop, it's only going to run once. Then we have our middle part, so everything between the first and the second semicolon. This is our conditional. And this just says, hey, is I greater than or equal to 3? And then our third part, which is I++, which just means, hey, let's add 1 to I. And so how the for loop is actually going to run this block of code here in this example is on the first iteration, the first thing that this for loop does when we start is it's going to say, great, let's create a variable, let I equals 1. Okay, that's the very, very first step, and we only do that once. The next step we say is, okay, great, is I less than or equal to 3? If it's yes, then we go into our code block. If it's not, then our loop is over. Okay? If it's not, just like with the while loop, if our conditional is false, if that middle part is false, then our loop is done and we've reached the end of this loop and we move on to the next line in the code. So in this example, we start off with let I equals 1. Is 1 less than or equal to 3? The answer is yes. Great. So then we move into our code block. We move into line 10, right? And we console log out I is 1. Once we're finished with our code block, then we actually jump to the third part here, which is say, okay, great. Now that I've done, now that I've run this piece of code, how did you want me to update or how did you want me to change the counter? In this case, how do you want me to modify I? And here, all we're saying is, hey, I++, let's just add 1 to I. Okay, that's the first run of our loop. In the second run of the loop, now we say, now remember, we only do let I equals 1 once, right? So now we go back to the conditional after I++ runs. We go back to the conditional and we say, hey, is I less than or equal to 3 still? And so I was 1 last run, then we added 1 to it, and so now it's 2. So the conditional becomes, is 2 less than or equal to 3? And the answer is yes, it is. So then we go into our code block and we run line 10 again, and we run back I is 2. After that line of code finishes, we then go back to our third part, after our final expression, and we run I++ again, right? So now 2 becomes 3, and then we go back to our conditional. We go back to our conditional, and then we say, is 3 less than or equal to 3? Yes, because it's equal to 3. We run our console log one more time, I is 3, and then we go back to our final expression. So let me just exit out so I can use my cursor here, right? Just so everyone knows, right? We started here, then we went to here. Sorry, we started. Oh, it's my keyboard. We started here, right? Then we went to here, right? When I equals 1. Then we went to here, and then we went to here, right? That was our first loop. And now all we're doing is we're going to be going from here to check to see if yes or no, should we keep going? If yes, then we do this. And after we do this, we then update our I variable. And so we just do this these 3 things over and over and over again until, so we left off at I equals 3, then we do I++, and now I is equal to 4. Then we check, is 4 less than or equal to 3? The answer is no, it's false. And so at that point, our for loop is over. Okay, so the way to kind of read this, so that was kind of the very detailed step-by-step walkthrough of how to read a for loop. Generally what people say is, well, I start tracking at I equals 1. I keep going until I becomes less than or equal to 3. And then every time that this runs and that holds true, I do this piece of code. And after every run, I update I in this way. Okay, so remember how in the while loop, we had this conditional still, right? Except with the while loop, we didn't tell the while loop where to start. And we kind of assumed or hoped that in that case, after every run, the I++ basically means, oh, we're gonna update our counter or update whatever it is in our conditional, so it gets closer and closer to the endpoint. We're doing the same exact things, the same exact thing here in the for loop. We're just being a lot more clear about each step, right? We keep our conditional, but now we're saying, hey, this starts here, and then after every iteration, this happens to it. So hopefully as a reader, when you read this, it's a little bit more clear about where you start and ultimately where you finish. Any questions on that? Or any questions on a for loop? Totally, go ahead.
Is there any reason why you would use while or for versus one or the other?
Generally speaking, I would say for loops are used a lot more commonly. I would say there's the vast majority of the time, there's no quote unquote reason. In that a lot of for loops you can rewrite as while loops or vice versa. For loops are a little bit more common because when you read it, it's just a lot more clear, especially in this line up here, kind of where you start and where you finish. Generally speaking, sometimes people use while loops when you don't know when a function is going to end. So an example of that would be if I say, hey, if I have a random number generator that spits out a number between 1 through 6, almost like I'm rolling a die, and I say, keep rolling until I get a 6. In that case, I might use a while loop because it feels a little bit more intuitive as to what I'm doing, right? It's like, I don't know when I'm going to I don't know when I'm going to get a 6, but I know eventually I will get a 6, right? So in that case, a while loop makes more sense. But even in that scenario, it's possible for you to rewrite that as a for loop. So all I'm saying here is just that, in most of these cases, like, you can do either one. I think generally speaking, people pick for loops just because it's a little bit more clear when you read it, kind of what's going on. Yeah. Line 7?
On slide 7,
Oh, slide 7. Sorry.
a for loop has 3 optional expressions. Does that mean that the initialization condition and signer were optional, or you have to include all of them all the time?
Yeah, great question. So for now, for the purposes of kind of us starting off, let's assume they're not optional, even though technically they are. And so the reason why they're considered technically optional is because if I'm changing my I somewhere else, I don't actually need a final expression, right? If I want my for loop to run in a different way, I don't need a conditional, and I also don't need an I as well. So that's why they're theoretically optional. But for now, especially when we're first kind of ramping up and practicing, let's just assume that they're mandatory for now. Okay.
Yes, thank you.
Yep. Yeah. Great question. And once again, another one of those like rabbit holes that like we could go down, but for now, let's just kind of keep it at the very foundational level as to kind of how we would use a for loop in, I would say 99% of the cases.
Syntax question.
Yeah.
Does it matter if you do plus plus I, minus minus I, or I plus plus minus minus? Is it slightly different, or can interchangeably use it that way?
In the context of a final expression, it does not matter.
Okay.
Because it evaluates the entire line and then moves on to the next line. There are cases in which it does matter. So when you do use that, just make sure that you know why you're using it in that way.
Okay, thank you.
Yeah. Any other questions?
I'm a little confused. Can you hear me?
Yeah, I can hear you.
Okay. So for the for loop and the while loop, do you have to like keep writing out the code, or does it just keep going on its own, just at one time?
Yeah, so if I take this snippet of code here and I paste it into a REPL and I run it, this just runs, right? This will run it 3 times.
Okay. And so it does it on its own until it can't anymore.
Yep. This for loop will just keep going until eventually this becomes false, in which case it will move to the next line of code. In our case, there is no next line of code, so it says I'm finished.
Okay. Thank you.
Yep. Any other questions? Awesome. So let's keep going here. So this is a for loop. And then basically once you know how like a for loop kind of works in concept, you can play around with a bunch of these, right? So here, we can do it in either direction. We can do it in either directions. And that just means here, instead of starting at I equals 1 and going up to a number by 1, here we're starting at 5 and we're going down to 1. And after every iteration, we're doing I minus minus, which means let's decrease I by 1, right? So this also works. And if we can do it with 1, we can also do it with any number. Here we're starting with I equals 100, and we're checking if I is less than 300. And every time after we do it, we just increment I by 100, right? So these are just numerical values. You can plug in any number you want. You just want to make sure eventually at some point your middle conditional is going to become false, right? Because there's nothing in a for loop that indicates, oh, you can only go up in number or go down numbers or go in one direction, right? You can just plug in anything you want, and it just every single step is kind of almost like an independent like mathematical expression. So something like this, it will run 3 times because we would start at 100 and then we would run our code and then we would add 100 to it. So now it's 200. We would run our code, we add 100 to it, and then be now 300. And then we would run our code, we would add 100 to it, it'd be 400. And when I equals 400, it would fail. And so that's why we only print out I as 100, 200, and 300. Cool. One thing so let's talk about like a more practical use case, right? When do we usually see for loops? One of the most common ways to, or one of the most common reasons for using a for loop is to iterate through something, right? In this case, we can actually use the for loop to go through an entire string. So here on line 2, I have this variable called letters, and it's equal to the string A, B, C, D, E, F, G. And notice how on my for loop, I start with I equals 0. I say I is less than however long the letters string is. In this case, it's going to be 7 letters long. And I plus plus, so I add 1 to it. And every time I go through this loop, all I say is let the current letter equal whatever is at the ith position of letters. Okay. Remember, all strings every single character in a string has a position, and the position starts at 0 for the first one, and it goes all the way down. And so here, every time I run this loop, I'm just getting a letter at a position in the string, and because I is always changing, I starts at 0, and every time it goes up by every time I run this function, or every time the loop runs, it goes up by 1. If I run this the entire time, I will have gone through every single letter in the string from left to right. Okay. Everyone still with me so far on this example?
Yep.
Cool. Yeah, one thing I just want to caution people who just be very, very, very careful with. I at this point is just a number, right? It's just a position. Letters index I on line 5 there, right? I is just a number. It's not a letter. This says get me the letter at the ith position. Okay, so if you use I and pretending like it's a number, your code's gonna break because I is a number, right? If I say letters and index at index I at position 0, then this will actually translate into a letter. And so if you ever are using a string manipulation, you're like, hey, my for loop isn't working, come back to this slide just to check it out, just in case that's where you're getting hung up on. Okay, so so we have a few more concepts here, and then we're gonna. Oh, sorry. Go ahead.
So on that slide you just had, I think what I'm understanding is if it was let n equal 0, n is less than n plus plus, then it would be letters n.
Yep, exactly.
Okay.
Yep, I is just a variable. You can name that with any variable in JavaScript. You can call it whatever you want.
Okay.
Right. So
that I in the 2 brackets, that's the same variable.
Exactly. This I here is used as the same I here. So I could easily do like call this like let this equal David, right? And if I just go through and I change everywhere where I have I into David, this function, this for loop's gonna work the same exact way.
Okay, thank you.
No difference. Yeah. Cool. So a few more concepts actually, and then we'll be actually be done. So this is going by pretty quickly. We have 2 keywords here. One's called continue and one's called break. Okay, so
sorry, can we
yeah.
go back to that last slide for 1 second?
Sure.
So David only exists, or the variable David only exists in the for loop, correct?
Yes.
So I can reuse the variable in another loop, or
Exactly. Yep.
it's not a global variable, yeah?
Yeah, we'll talk more about global variables when we talk about scope, but for now, yes, David can be used inside this for loop.
All right, thank you.
Yep. Any other questions on the slide? Cool. Okay.
Wait, I have a question.
Yeah, I knew it was coming.
Sorry. So why do you need a variable for letters I? You can just do console.log letters I.
You could. Yeah, I mean, this is a variable, right? So, I mean, every variable is just meant to be like a shortcut or a representation. In this case, it's not that much more of a shortcut, but there's nothing wrong with this. The question becomes like, what if I want to print this out like 5 times, right? I guess, or if I want to modify this, then it gets a little bit wonky. But you're absolutely right. Here, I could get rid of that line and just do something like this. Right, now instead of using a variable, I just use the value directly. Totally fair. Okay. Any other questions on this page? I don't believe you all.
I think we're good now.
Okay. Cool. All right. The continue keyword. The continue keyword basically is something that you use inside the loop. And it's actually a very simple concept. All it does is, if I think about the way that the body of the code, right? The body of the code may have several different lines here. Whenever I hit the continue keyword, it basically just says, oh, okay, don't read the rest of this iteration of the code, but go move on to the next iteration of the code. So what does that mean in practice? Here I have a for loop. I start at I equals 1. I do I is less than 5 and I plus plus. And then here what I do is, if I do say is, hey, if I is equal to 3, continue. Otherwise console log I is 1. I is I. Okay. So when I print out this function, the first time it runs the for loop, I is 1. Is 1 less than 5? Yep. Great. Let's go into the body of our loop. Is 1 equal to 3? Nope. So we skip line 4. We go to line 7 and we print out I is 1. Same thing happens with I is 2. When it gets to I is 3, we then say, okay, great. Let I equals, or now I equals 3. Is 3 equal to 3? It is. So then we go to continue. And all continue does at that point is it skips lines 5, 6, and 7 and says, hey, go to the next iteration of the code. Right? So then after I equals 3, we go straight into I++. So now I is 4. And then we check again, is 4 equal to 3 in our block of code? And no, it's not. So we skip line 4, we go to line 7. So that's why we print out I is 4, and then we print out I is 5. Okay, so all continue does is whenever you hit continue, it basically just means let's skip that instance, or let's skip that iteration, or sorry, let's skip the rest of that block of code, but do go on to the next iteration. Okay, that's all it does. It's saying keep going with your overall loop, but let's just skip the rest of this iteration. Let's skip the rest of this turn. And so if I use a while loop, same exact idea here. All in this case, if I look at my continue keyword, all I'm saying is on line 7 there is, hey, let's start with count equals 5, right? On line 5, I say if I do a remainder when I divide it by 2 is 0, so which basically means if it's an even number, let's just skip lines 8, 9, 10, and 11, right? This just means the rest of the loop keeps going. I'm just going to skip the code in the rest of this run. And I'll pause for questions in 1 second. But let's contrast that with another keyword, break, right? And when I say keyword, once again, reserved words in JavaScript, okay? So break, what does break do? Well, what break does is break actually just says, hey, skip the rest of this run and also skip all future runs too. Basically, what it means is whenever you see break, it just means end this loop here now. Like don't run anymore. So with the continue keyword, it was like skip the rest of this iteration, but keep running. Break says skip the rest of this iteration and stop running altogether. That's basically the main difference between break and continue. Continue lets you keep going. Break ends everything then and there. And so I'll go to the for loop example because I think a little bit more intuitive here. Here I have this loop that starts at I equals 10. I'm trying to go down all the way to I is equal to 1. After every iteration, I decrease I by 1, I minus there in my final expression. Notice how on line 5 I say if I is equal to 7, break. That means when I console log out these things, I console log out I is 10, I is 9, I is 8. I go to after I console log out I is 7, I hit line 5, I say is 7 equal to 7? Yes it is, break. And now my for loop just ends permanently. Okay, that's the main difference between break and continue. It's just that after I skip the rest of this iteration, do I keep going on to future iterations? Any questions on those?
Can you explain the continue one again?
Sure. Continue just says, so right now in this block of code that we see on this page, every time we run the for loop, we would think that lines 3 through 7 runs every single time, right, for every number. But if we hit the continue keyword, right, so in this case, continue is only triggered if line 3 is true, if the if statement is true. If we hit line 4, then it just means let's skip lines 5, 6, and 7.
Okay, so like, I don't know. So if the I in the parentheses becomes 3, then it's not going to show up as I is 3. Is that what it means?
I think it's throwing away that cycle of code where the value is 3, so it doesn't print it for you.
Okay, so here, right? So let's just run through this code, right? When let's say on our first iteration, here I'll say I is equal to 1, okay? Right? So when I is 1, this is not true, so I skip line 4 and I go to line 6. Let me run this. Okay? So far so good, Genesis, right? On my next iteration, I is 2. I run this. This is not true, so I skip 4 and 5 and I run line 6. Right?
Okay.
Next iteration, I becomes 3. And is 3 equal to 3? Yes, it is. So I hit continue. And that means I now move on to the next iteration right away of I is 4.
Oh, okay.
So I skip lines 5 and 6, basically.
Okay. Thank you. I needed to actually
Yep.
see it.
No problem.
Thanks.
Yeah. And yes.
Is there a reason why you would use break instead of changing the conditional so that it ends where you want it to break?
Yeah. Conditional usually implies that you know when you want to break, and sometimes you don't know when you want to break, right? Like if I go back to my dice rolling example, like theoretically speaking, even the dice rolling example, you should be able to know when. But you actually come across a few cases in which you don't know exactly when you want to stop, or you only want to stop if a certain thing is happening that's independent of your conditional. So it's not used very commonly. By all means, like most loops don't make use of it, but we just wanted you to know that it's there. It's almost kind of like an emergency exit button.
Okay, thank you.
Yeah.
So David, is break and continue only used with loops?
Yes. Or at least for our purposes, yes. If you use it in a function, for now, let's just keep it within the realm of loops.
Okay, thanks.
Yeah. Any other questions?
When you showed that one while loop where you skipped even numbers, you could have done that with a for loop as well, right?
Totally. Absolutely.
Okay.
Yeah. Anything I can write with a while loop, I should be able to do with the for loop, theoretically.
Okay.
Yeah. Cool. All right, so that's pretty much it for loops, right? So these are things we want to cover: a while loop, cover a for loop, cover the continue and the break keywords. May seem simple, but when you do the workshops, we'll see. There's a section on debugging too, and I'm actually gonna not go into as much depth on the debugging session, and the reason why is because the the slides tries to kind of show some helpful like tools to use kind of almost outside of kind of the code editors that we have, and in my experience those actually do more harm than good at this stage because I don't want you to get lost in the debugging software. So we'll talk about like the basic general errors that you'll see, and then I have a few more slides for people who use VS Code or Chrome, and you can kind of figure out, you can take a look at yourself, but I don't want to do it as a class because I've noticed that those things actually make it harder for people because it's almost like you're learning something new on top of learning something new. So debugging is just fixing code that doesn't work the way you think it does. And the reason why we actually have you use CodePen is because we run basically tests on them. And these tests, yesterday in your workshops, all the tests started off green. You have passed everything. Everything was good. That will never happen again, right? You'll never start off in that situation. Now when you start off, every single test is going to fail. And so whenever you run your functions, you're going to see on the basically the screenshot on the right hand side, it will tell you how many specs or how many tests there are and how many have failed. And for each test, it will say the name of it'll see, let's do it here. It will give you the name of the test. In this case, the test is called only odds returns a number. And it will also always give you back the error or at what point it failed, as well as these things down here, which we call the stack trace. And this tells you which lines of code were run until it got to the error. Okay, so this is the name of the test. The error you got here is reference error, which we'll talk about in 1 second. And then the last line I ran before we got to this error was only odds on line 11, character 7. Usually we don't care about the character, we just care about line 11. Okay, so in this, the unit test will always give you back an error. Just keep in mind that the error may not exactly be what the issue is, right? You may break something in step 1, and on stage 3, and then step 3 tries to use it, and then it breaks there. So say, oh, there's an error on step 3, but really the error was caused all the way back up in step 1. Okay, so any error messages you see, think of it as the beginning point for your exploration. It's not always like the exact direct answer. So in this case, the error we see here is something called reference error, and reference error just means, hey, you're using a variable that you haven't created yet, at least in this place. when we talk about scopes tomorrow, I'll talk more about reference errors. For now, more often than not, you get reference errors when you misspell variable names. That's probably the most common reason for reference errors. Basically, you create a variable and either you misspelled or something, and now you're trying to use it, and JavaScript says, "Hey, I don't know what it is." The other reason for using a reference error is just because you never create a variable in the first place, or you're using it outside the proper scope. But that's something, once again, that we'll talk more about tomorrow. Okay, so reference errors is the first error, and this is just a walkthrough of these lines to tell you kind of where the error occurred at. There's two kinds of failed tests in our testing, right? The first one is kind of almost like, hey, you misspelled a variable name, or hey, this code just can't run, right? You forgot a semicolon in your for loop, you forgot this or that. It's just like not correct. Like the code itself cannot run. That's the first kind of error. The second type of error is saying, hey, your code ran. It just didn't give me back the answer that I was expecting, right? So in this case here, whenever you see something like expected blank to equal blank, the first blank is what your function gave back. So your function ran successfully, if you will, but it gave back an answer that wasn't what we were expecting, right? In this case, it's saying, I expected to get back 25. Instead, your code gave me back 55. So there was no errors in terms of how it was written. There was an error in the logic underlying the code. So when your tests fail, just always keep that in the back of your mind. Is this test failing because the logic is wrong or because the code itself is wrong? Okay. And once again, and then just one last thing is just when we talk about these tests, just always be sure you understand, like we try our best to kind of tell you what the test is supposed to be doing, but always be sure you understand what's breaking something before you try debugging it. Yeah, and then the last thing we'll also talk about is just the last thing I'll mention here is console logs are really great for us to read, but, and this is super critical, return statements are what actually gets returned out of the function, right? So when you read the directions, if it says, hey, write a function that returns something, have a return that, right? Every function in JavaScript returns something, and if you don't tell it what to return, then by default it will return undefined. Okay, sorry, there was a question.
Nope, we're all good.
Oh, cool. And that's pretty much it. Like I said, you will see all of these when you do the workshop. So, I could answer like any kind of burning questions now, but when you start working on the workshops, it'll become really clear to you really quickly where these errors are coming from. And like I said, there's a few more materials here about like other tools that you can use. In terms of like VS Code or debugger. But like I said, if you want to ask me about them, I'm happy to talk more in the kind of like offline, maybe after class or before class one day. But like I said, like in my experience, they actually kind of hurt more than they help at this point. Okay, so console logs are really great for you to see what's going on. But if a function says, I need you to return something, please return that, actually return that thing. So any questions primarily on the loops portion, because the debugging thing is going to be a part of our experience for the next 3 weeks. Actually, so will loops, but